back. Today we're looking at the exponential basic equation part 2, and now we're really getting into the reasons that we use our exponential functions in life, in sciences, in finance. We're looking at word problems. I know some of you guys hate word problems, but as long as we know what we're looking for and what to do with it, then we should be okay. A lot of these, they have this stuff written out for you. It's pretty straightforward. They're not trying to confuse you at all. They're just making sure that we know how all the parts of our exponential equation works. So we're looking at exponential growth and decay, and the basic form is y equals a parentheses 1 plus or minus the rate to the t. Now, two things to note is that the rate, it must be a decimal. So pretty much every time we have one of these exponential growth or decay problems, they're going to give us a percent. Our job is to change that percent to a decimal before we apply it. If we don't do that, we're going to mess up our calculations. It's going to be our answer is going to be wrong. It's going to be way bigger or way smaller, because exponential growth, just a little bit of change to the multiplier is going to give our end amount, is going to change our end amount a lot. Also, it's going to ask you about if we have a growth or decay problem. If whatever is inside of this parentheses here, this 1 plus or minus rate, is larger than 1, that means that we're growing. That means we're multiplying by something bigger than 1. Our number, each time we multiply again, it's going to increase. Whereas if our parentheses is less than 1, 0.13 or point something, then we have a decay. And all that means is that each time we're going to lose an amount of whatever we started with. All right, so let's kind of look at some examples here. There's 3 examples. The first one is saying, let's say the rate of inflation is 2.6% per year. Right now you currently have $1,500. So the inflation means, so let's say in the 1940s or 50s, like my grandma would say that candy was like a nickel or a dime back then, right? So obviously now we can't buy much for a nickel or a dime, not even close to a candy bar. A candy bar is probably $1 or more right now. So the inflation means that the amount of money that you have is not worth the same value as it was in the past. So inflation, that 2.6% is a reflection of that. So it's giving us this model here. P of t is equal to 1,500 parentheses 0.26 to the t. Now, this is not important as much in this problem, but let's go ahead and point out some things about the equation. So $1,500, that's how much we started with, right? That's the initial amount that we've been talking about, right? That goes in front of our parentheses. Now, the inflation is 2.6%. So when we have 2.6%, if we want to change a percent to a decimal, we can move this decimal point twice to the left. Oops, sorry, that's not twice. Twice to the left. So it would be 0.026 as a decimal here. Now inflation, we assume it to be increasing, right? The amount of money we need to spend to get the same thing every year is going to increase. So that's why it's 1 plus, right? If we look back up here, it's 1 plus or minus, because inflation is a growth rate. We're adding the 0.26 to the 1. And then the t represents the amount of years. Okay, so part A is really easy. We can just look at our equation. It's asking how much do you have currently. That's the initial value. Without doing any math, we could just say 1,500. Now, the other way to do it is we could say, all right, That just means if time is 0. That's how much we have currently. So then we go ahead and plug our 0 into t. You could punch all that into your calculator, 1,500 parentheses 1.026 to the 0 power, and we come out with the exact same answer. All right, so for the price in 9 years, that would be the P of 9. Our T is 9. We're going to have our 1,500, 1.026. Our T is going to be 9. And if we plug that into the calculator, and let's round to the nearest cent, right? Because that's what we measure, and you don't ever have something less than cents when we're talking about money. So if we put that into our calculator, we end up with rounded 1889.81. 1889.81. So what it's saying is that if we're trying to buy something that's $1,500 today, I don't know, something that like a new gaming laptop, I'm not sure, something like that, right? That costs $1,500. In 9 years to buy that same type of laptop, what it would cost would be $1,889.81, and that's due to inflation. Now, obviously, gaming laptops would probably be a bad idea because those change. But let's say we did something whose value doesn't decrease over time, like, I don't know, what can we buy now with $1,500? Maybe like a pool, right? An above ground pool. In 9 years, that same pool will cost $1,889.81 due to inflation. All right. Let's look at another example. So the value of a house that is T years old is modeled as V of T equals $325,900, parentheses 0.79 to the T. All right, so one thing to notice here is that 0.79, that's less than 1, right? 0.79 is less than 1. So this is gonna be, let's already jump to here and ask ourselves, is it a growth or decay? Well, we said anything less than 1 is a decay, so this is a decay. So sadly, this house is losing value every year. Most of the time, houses don't lose value. They increase in value every year. But for some reason, this one is decaying, which is sad. But anyways, yeah, one thing to note here. Now, the initial value, again, we can just find whatever is in front of the parentheses. The initial value for this one, so we bought this house for $325,900. The other way to do it again was we could just, initial value means if the time is 0, so we could plug in a 0 to our T and we'd get the same amount. Now, number 3 is asking us what is the percentage change. So percentage change, this is a little bit tricky thing. But percentage change means how far from 1 in the parentheses. So 0.79, how much would it take for us to get to 1? How would we find that? Well, we do 1 minus 0.79, and that would give us 0.21. Now the percentage though, we have to convert 0.21 to percent. So I'm gonna take 0.21. This time, because we're going from from decimal to percent, we move to the right. So this is gonna be 21%. All right, so again, the percentage change just means how far away is it from 1. So in this case, it was 0.79. We're going to take that 0.79, subtract it from 1. That's going to give us 0.21. But it's asking us for the percent change, so we need to convert that decimal into a percent by moving it 2 to the right. Once we move our decimal 2 to the right, we end up with 21%. Now, just another example here. You don't have to write it down, but let's say we had something bigger than 1. Let's say we had 1.13%. What is the percentage change here? Well, that's easier to figure out. How far is it from 1? Oh, sorry, it shouldn't be a percent. 1.13. How far is it from 1.13? Let's change that to a decimal. Move it to the right. That's 13%. Right, so numbers that are greater than 1 are a little bit easier because the number's right there. We didn't have to subtract it from 1 to figure out how far away it is from 1. Okay, last example. This time we're trying to write a function. So at the beginning of a study, a forest was 1,500 kilometers squared, or square kilometers. The area has decreased by 6.6% per year. So sadly, this forest is getting smaller. It's decreasing by 6.6%. We want to write a function, so let's do y equals. We don't have to write all this stuff in. We can just kind of talk about it. So this is going to be the a, and then 1 plus or minus the rate. And then our time is in years. Okay, so first thing we're going to do, let's take this 6.6%. Let's convert it to a decimal. So 6.6%, we're going to move that decimal place over twice. So this becomes 0.066. This is our rate. So let's go ahead and fill this in. Our initial amount is 1,500. So we're going to say 1,500. 1. Because it's decreasing, we're going to subtract, right? So we're going to subtract 0.066. Our t doesn't change. Now all we have to do is subtract that. So 1 minus 0.066 is 934. And then we're done. You guys can go ahead and fill this in. You might actually be able to plug in the top one to Alex, and that might also be acceptable. You can go ahead and check if you don't want to subtract. But yeah, all it is putting in the correct numbers in the correct places. Again, just make sure when we're filling in our equation that we change our rate like we did here from a percent to a decimal, and then we should be right. We're just filling in the proper spaces in our equation. All right, so next time we're going to be talking about compound interest and stuff. That's another pretty cool thing when we're talking about investing money and how much money we can get. There's a way that you guys can figure out how to save early on in your life so that you become millionaires when you retire, but it takes investment early, and yeah, you'll see how the exponential growth thing works as far as the compound interest. All right, make sure you take your notes. Make sure you have any questions that you bring them to us in class in next class, and I'll see you next time.